The slat anti-ice system utilizes hot bleed air from the engine to supply thermal energy through the slat anti-ice valve via the telescoping duct to the slat 2, 3, and 4 piccolo tubes. Holes in the piccolo tubes cause the hot air to impinge on the inner surface of the slat, creating the heat needed to prevent ice on that slat. The AMS controller receives signals from the pressure transducers and from the slat skin temperature sensors to modulate the slat anti-ice valve. System automatic operation is activated by the ice detection system. However, in flight, the pilot can override the ice detection system and actuate the slat anti-ice manually. The selector switch is provided on the cockpit control panel for ground tests. The slat anti-ice valve located in the pylons is a butterfly valve powered by a pneumatic servo actuator. The valve modulates to maintain the required flow to the slats for anti-ice, controlled by the AMS controller. Duct pressure is ported directly to the supply of the actuator piston. This pressure force and the spring force provide the closing force for the butterfly disc. The opening force is provided by servo pressure acting on the larger servo piston. The servo pressure is controlled by a torque motor mounted on the valve, which receives an electrical signal from the AMS controller. The anti-ice flow is based on altitude, ambient temperature, Mach number, and slat position. The microswitch installed on the valve indicates a closed position or valve modulation. The signal is also used for built-in test purposes. The slat anti-ice temperature sensor is a dual-element platinum resistance sensor which monitors the slat skin temperature. 3 sensors are mounted on each wing outboard of slat 2 and inboard and outboard of slat 4. During normal operation, the middle sensor on slat 4 is used for the calculation of proper ice flow. The remaining 2 sensors are used for health monitoring to ensure that hot air covers the entire area where ice protection is required. The slat anti-ice pressure sensor is used to monitor duct pressure downstream of the slat anti-ice valve on each wing. The sensor sends an electrical signal to the AMS controller, which is used for system control and health monitoring. The sensor is hermetically sealed and consists of a pressure port, pressure transducer, and electrical connector. The sensor receives 28-volt DC excitation voltage. The slat anti-ice system contains a telescoping duct on each wing to connect the piccolo tube with the anti-ice pressure supply duct. The telescoping section of the duct is Teflon-coated stainless steel, which rides on 2 bearings. The telescoping duct extends and retracts with the wing slat and allows uninterrupted flow during wing slat actuation. The slat anti-ice system contains steel piccolo tubes that run through the wing slat. Regulated bleed air flows through the telescoping duct and pressurizes the piccolo tube. The piccolo tube contains holes that allow hot air to flow out into the wing slat chamber for heating the slat skin. The piccolo tube consists of 3 separate duct sections. When assembled into the aircraft, these duct sections are connected in between slats by flexible sleeves to allow movement. The slat anti-ice protection system can be operated in 2 different modes, auto or override. Selectable on the overhead control panel. In auto mode, the ice detection system will actuate the system operation, while override can be selected manually in the air. In both cases, the slat pressure regulating shutoff valves are modulated by the AMS controller. The desired skin temperature is calculated as a function of slat position, ambient temperature, Mach, and altitude in the range of 71 degrees Celsius, 160 Fahrenheit, to 121 degrees Celsius, 250 Fahrenheit. The AMS controller calculates the desired skin temperature to determine a duct reference pressure. The controller then compares the calculated and actual duct pressures measured by the pressure sensors. The AMS then modulates the pressure regulating valves by increasing or reducing the torque motor current. If a fault is detected that disables anti-ice flow on one wing, the system will automatically command the opposite wing's anti-ice valve closed. The following slat anti-ice system status, advisory, or caution messages can be indicated on the ICUS. Status message, anti-ice wing valve open from the valve position switch. Advisory message, anti-ice mode not auto if the mode selector is not in auto mode. Advisory message, ice condition when ice is detected in flight. Caution message, anti-ice, low capacity if air is commanded on and the system is not failed, but the pressure or temperature is low for slat anti-ice. Warning message, anti-ice wing leak if the detection loop signals that internal temperature of the slat exceeds 130 degrees Celsius, 266 Fahrenheit, for 30 seconds, or internal temperature exceeds 150 degrees Celsius, 302 Fahrenheit, for 2 seconds. Caution message, anti-ice wing fail when valve fails, or due to asymmetric operation, over temperature, over pressure, or piccolo burst. A caution message, anti-ice wing no dispatch, is displayed whenever a wing anti-ice bleed valve has failed open. The slat anti-ice system contains test logic that monitors the performance of the system components. Any component or sensor failure will be indicated through the aircraft diagnostic and maintenance system, or via the ICUS. The anti-ice synoptic page also indicates the system temperature, pressure, and valve positions. In addition to the built-in test, it is possible to test the system by using the control panel test switch. When bleed source is available, the engine or APU and the wing anti-ice switch are on, then selecting the test switch to the wing position will activate the slat anti-ice system.